Good morning, my dear students. Welcome abroad. I'm super excited to start such type of online classes after a very long time. Being the first day, today I'll be introducing myself. My name is Atom Santi, and you can call me AS in short. And I have been working in this school for the past 15 years, and I will say that I'm quite capable to teach you physics. And and I'll be talking about this, the structure of the online class that we are supposed to have. Actually, as far as there is no technical issues, I'll be trying my level best to upload such type of interactive video classes, and I also know that it is quite effective to learn better. Okay, coming to our school again one more time. Since today is the first day, I need to talk something about our school. Okay, so we have separate departments. We have physics department, we have biology department, and we have this chemistry and home science, geography, like that. We have different departments, and since I am in physics department, I'll be talking about this about my department a bit more. We have two teachers. One is myself, and the other teacher is Miss Sangi. She will be taking up half of the whole syllabus, and the other half will be taken up by myself. And our physics department is well equipped with, with the equipments that is up to the standard as prescribed by the Council of Higher Secondary Education Manipur. And normally we used to have practical classes. We have a good laboratory where we used to perform experiments and all. And the next point what I want to talk is about the syllabus. Your physics class 11 physics syllabus will have altogether 11 units. And about the division of the classes, Miss Sangi will be taking up from the first unit till the 5th unit, and I myself, I'll be taking up from 6th unit to the end. So basically we are going to have two groups, let us say, and the first group belong to your miss, and the second group belong to me. And we'll be posting contents. Content means the notes or the classes, this type of classes like this, by the concerned teachers. And the second point, I mean the next point, what I would like to say is try to have a good quality book. And I know if you look at the syllabus, there is a list of recommended books that you can purchase from the market, and especially please do not go with only the basic prescribed book, because in the council syllabus only the basic books, that there is the NCERT textbook is being prescribed. I strongly recommend you to have some other reference books. Okay, maybe Dinesh Millennium Physics, or maybe Modern ABC, or maybe Saraswati Publication, or maybe Pradeep's Fundamental. Any one of those reference books you please try to have, because only the prescribed book as given in the council syllabus is not sufficient. Is not sufficient to to fill all the all the gaps. What I mean to say is that those books being prescribed as the standard textbook by the council is not going to give all your requirements. Okay, so you need to have some other reference books as well. Okay, being the first day, I'll be introducing you briefly about this unit number 6, that is gravitation. So let's just go to the board. I'll be tilting up the camera so that you can see. I have already written the syllabus as well. So let us have a look. Let me just zoom the camera. Okay. All right, I think you can see right now. Okay. As you can see, I'm writing unit number 6 here. There's gravitation, and this will carry 5 marks. And the syllabus has been reduced. In such a way that you can digest the whole syllabus easily. And comparing to the old syllabus, this syllabus is quite small, I would say, and quite easy to learn also. So in one way, you are quite lucky to have such type of smaller syllabus, because you know, when the syllabus becomes small, you can learn faster. That's fine. Now let us see. In this unit, we'll be talking about this the universal law of gravitation, and the second one is gravitational constant Z. Okay, I'll go through all this syllabus briefly. In this universal law of gravitation, what are you going to learn? You are going to learn the attractive forces that binds all the bodies together. For example, say Earth, and this is you, for example, and you all know that you are bounded by the gravitational field of the Earth. In other words, you are being attached to Earth. There's something binding it together, okay? Something like binding together. So this type of attractive force, this is what we call as a gravitation. So we'll be talking about this gravitation in a very brief way. So whenever we see this one, universal law of gravitation, there is a law which is what formulated by Isaac Newton. So according to him, every body, maybe between the camera and myself, or maybe my body and this wall, whenever you take different bodies, they are being attracted. There is no question of repulsion. There's all the time talking about attraction, all the time attracting each other. So whenever you talk about these laws of gravitation, always remember that different bodies interact. It means what? They used to attract each other. So that type of attractive force is what given by Newton. So there is a separate law we call as the Newton's law of gravitation. So under this universal law of gravitation, you're going to talk about interaction or attraction between different bodies. So what are those bodies? These bodies can be any that has certain mass, okay? But remember that the interacting bodies, or the bodies which are actually interacting, they should be having what? Their own masses, okay? If they don't have mass, means there will be no attraction, okay? So under this universal law of gravitation, in short, we are going to talk about the attractive force between what different bodies, right? Okay, it's very easy. And we have this gravitational constant. So there will be a constant. So this constant, what is this all about? This constant will be extremely helpful in the study of interacting forces. For example, say you have two bodies, one body is A, another body is B. For example, say you want to calculate how much is the attractive force, how strong is the attractive force, for example. So in calculating the attractive force between two different bodies, you need to use this constant, which is what we call as the universal law of gravitation, okay? I'll be introducing that also. And coming to the second one, gravitational potential energy. What is all about this one? For example, say this is the Earth. So you have a body which is above the Earth, okay? Above the Earth's surface, you know? Say just like, some heavy body which is flying in the air, for example. What you have to know is that this body is being attracted by the Earth. So if the body is released freely, suppose this is the body, you just release it freely. If you release the body freely, the body has a tendency to fall, isn't it? The body will surely fall. The question is that why is the body falling down? Why is the body falling down? Simply because the body has energy, okay? Without energy, the body cannot move, you know that. So that type of energy possessed by the body, I repeat again, the type of energy possessed by the body, okay? Energy possessed by the body so that it may have a tendency to fall. So the type of energy possessed by the body. So that is what we call as a gravitational energy. Okay, gravitational energy, gravitational potential energy is there. I'm not explaining very briefly this one. In the second class, I'll be talking about that. Just for today, I'm just showing you what it's all about. Okay, so in other words, gravitational potential energy is simply the energy possessed by a body when the body is in the air. Okay, or maybe. So think of some other cases. All right. Then you have gravitational potential. These two are in the same group. We'll be explaining briefly about these two. And then it comes escape velocity. For example, say if you want to escaping, just like escaping from a prison, just like going out without permission. Okay, for example. So if you want to escape or if you want to fly out away from the Earth's gravitational field. If you want to fly out or if you want to go away from the gravitational field of the Earth, you need to have a minimum velocity. You need to have a minimum velocity, so that velocity is known as what? Escape velocity. Okay, normally if you happen to jump up, you will surely fall down. No matter how high you throw the body will surely fall down here, because you are not throwing the ball with a very great velocity. But in case if you happen to throw the ball with a very great velocity, the body will not return to the Earth again. Okay, so that velocity to be possessed by the body, so that it may not come back to Earth. That velocity to be possessed, okay, to be possessed by the body is what we call as a escape velocity. It simply means that the velocity required by a body so that it may escape from the Earth's gravitational field. Okay, that is what we call as the escape velocity, right? Then it comes orbital velocity. What is orbital velocity? For example, say this is the Earth. This is Earth, and there is a body which need to move around the Earth continuously, all the time moving around, just like the satellite. Okay, just like a satellite. The satellite used to go around the Earth. You know that. So if the body is supposed to go around the Earth continuously, not going away at the same time, not coming closer to the Earth. So if this body is supposed to go around Earth in a fixed orbit, in a fixed path, this body must possess a velocity. So that velocity required by the body is what we call as the orbital velocity. In other words, you just choose a body and the body need to go around the Earth. Say this is Earth. The body need to go around the Earth continuously in a fixed path, in a fixed orbit. Okay. So the energy to be possessed by that body is what we call as the orbital velocity. Easy. Okay. Then next we're going to talk about the satellite. I mean the SCHSS satellite, those type of satellite that remain fixed, like say remaining fixed, not moving out away, okay, from a particular place here. So we are going to talk about the SCHSS satellite. In short, we're going to calculate, okay, the velocity as well, and the height, everything. So actually, this is purely based on mathematical calculations actually. So I'm just showing you briefly what we are supposed to do. So that mathematical tool, there are some requirements. Especially you'll be talking about this differentiation. Okay, differentiation, we'll be talking about this. And next you have integration. Okay, so these things we need to learn it first before we actually start the classes. So today being the first day, I'm just introducing you what we are supposed to do during this our online session of the online classes. So basically I feel that you should learn differentiation and integration separately, and actually these two, differentiation and integration, belong to mathematics portion, though you may not be offering mathematics. I'll be taking a separate class on it. Okay, this is the brief introduction, and I'm very happy to say that we are able to start our online classes from today itself. So just for today, I'll be giving you one small assignment, just something that you need to memorize during this time. Time means what? When you have the free time, just try to memorize it. I'll be giving you let's say value. I'll be giving you this one, the value of universal gravitational constant. You just try to memorize it and keep in hand. Whenever we need it, we should be using this one. So first of all, you memorize this. I'll be introducing a small law, that is Newton's law of gravitation. Okay, let's have a look at this. Let me write here. Newton's law of gravitation. According to this law, what you need to know is just choose two different bodies. Okay, one body is here, another body is here. You have another body here. This one is having a mass of m1, let us say, and this one has a mass of m2, maybe 1 kg, 2 kg, like that. Okay, then these are separated by a distance of r from center to center, maybe 1 meter, 2 meter, like that. Then the force between them, there is an attractive force between them. The force will depend on the masses here, m1, m2. This is the first equation. Okay, it means that if these two masses are becoming bigger, suppose that this is big, then the force becomes stronger. Okay, there will be more attractive force in case if the two masses are increasing. Okay, suddenly this is increasing from 1 kg, it is becoming 10 kg. This also from 1 kg is becoming 20 kg, like that. You know that the mass is increasing, right? In that case, the force of attraction also increases. And the second one is F depends on R inversely, here, opposite here. This is the inverse relation. So if R is increasing, F is decreasing. It means that if you keep the two bodies very, very far, like this, very, very far, you are increasing R. So if you increase R, what happens? The force decreases. It means that the attractive force decreases. Okay. So if you combine these two relations, what do you have? You have this. F is here, m1, this is m2, this is what? R. Then you have this, F is equal to Z m1 m2 by R. Oh, this should be R square. Okay, that should be square. Sorry for that. Should be square here, like this. So this is what we call as the, what do we call it? Newton's law of gravitation, right? And here you can see a constant, isn't it? So this constant is what we call as the universal gravitational constant. This one I want you to know this one. This is known as universal gravitational constant. Okay, so try to memorize this formula for today, and if you learn it, you will learn this gravitation faster. So for today, this is the formula I'm giving to you. So just try to memorize the formula and get ready for the next class again. Okay, bye.